Hi, I'm here to show you about a rubber band desktop model of Einstein's theory of special relativity. Using this model that I've built, I'm going to show you how you can visualize one of the most fundamental aspects of our modern time, and that's Einstein's theory of special relativity. And the way this model works is that it demonstrates, it helps you visualize some of the solutions to the Sine-Gordon equation. One of the solutions to the Sine-Gordon equation is called the kink. And the kink looks like this. And what we use this kink for is to show what a measuring rod would look like in a conceptualized universe. And this measuring rod has a distance from this point here to this point here. And the other most important aspect of this model, the Sine-Gordon equation, is something we'll call a breather. And a breather is the way to measure time in this universe. And a breather has a period of the time it takes to go from here to the time it takes to go from here. And so under normal circumstances, when everything's stationary, kinks have a constant wavelength and breathers have a constant period. However, when you accelerate this frame of reference, the kinks begin to contract and the breathers begin to dilate, just as predicted in special relativity. And we can demonstrate that with this model. So what we can do is we can start a kink propagating down the line. And as it speeds up, the wavelength, which is the distance between here and here, begins to contract. And it begins to contract and get smaller. The same thing would, if it were possible to use this model to show how a breather would contract, we'd see that instead of going like this, the breather would go much slower as well. And this is a model that I've been building, and it has a baseboard, and then in between each one of these pendulums is a rubber band, just like the one seen on this giant rubber band ball right here. And the way it works is the nonlinearity of the way these rubber bands stretch. So as the pendulums begin to fly out further, it begins to stretch more and more, but it takes more energy to stretch at that last bit, just like in special relativity, where to get your measuring stick to contract all the way, you have to be going at the speed of light. And that's my model on a rubber band model of Einstein's theory of special relativity on the desktop. Thank you.